Chemical and photochemical reactions in the atmosphere. The study of chemical reactions in the atmosphere poses the serious problem due to very low concentration involved, which makes the detections and analysis of the reaction products extremely difficult. High altitude reactions at the very low pressure can't be simulated in the laboratory. The chemicals in the atmosphere participates in the photochemical reactions by absorptions of the solar radiations. Such reactions occurs even in the absence of the chemical catalyst at a much lower temperature. These photochemical reactions play a key role in governing the ultimate fate of the chemical in atmosphere. Some typical chemical and photochemical reactions will now be illustrated. It should be noted that the atmosphere is a tremendously dynamic system with wide fluctuations of the parameters, compositions, temperatures, humidity, intensity of the sunlight. Obviously, the different process will be observed under very atmospheric conditions. Sulfur dioxide. There are three possible routes along which sulfur dioxide may react: photochemical reactions, photochemical and chemical reactions in presence of nitrogen oxides or hydrocarbons, chemical process in water droplet containing metal salt and ammonia, reactions on solid particles in atmosphere. Sulfur dioxide absorbs the solar radiations in the regions of 300 से 400 nanometers, 300 to 400 nanometers. Particularly in the lower atmosphere, they produce electronically excited state of the sulfur dioxide. So sulfur dioxide absorbs the radiations and form SO2 star, excited sulfur dioxide. In natural sunlight, at the 5 to 30 ppm level of the SO2 and relatively humidity 32 to 90%, the overall reaction is SO2 plus half SO2 plus half oxygen plus water, and that will form the sulfuric acid. Which is permitted by the presence of hydrocarbons and nitrogen oxides. The key components of photochemical smog. The free radical HO present in photochemical smog also contributes to oxidation of SO2 to make a sulfate. Free radical of OH plus SO2, so HOSO2 free radical, HOSO2 free radical will react with the oxygens just to formation of HOSO2 O2 free radical. And such products HOSO2 O2 free radicals will react with the nitrous gas NO, and that will form NO2 plus HOSO2 O free radical. In relatively humid atmosphere, SO2 is probably oxidized by reaction occurring inside water aerosol droplet, which proceed faster in the presence of ammonia catalyst such as manganese second, iron second, nickel second, copper second, So ammonia will react with SO2 in the presence of water and formation of ammonium ions, positive ions, HSO3 negative will take place. Again, this ammonia will react with HSO3 negative, and that will form the sulfite or ammonium active. Solid particles such as soot provide the heterogeneous phase for catalyzing the oxidation of SO2. Soot particles are the common features of polluted atmosphere. There is evidence of the presence of this sulfate in soot particles from photoelectron spectroscopy. Sulfur oxide, one of the serious air pollutant, is the responsible for smog, resulting in several incidents of the loss of the human lives. It also contributes to acid rains. Now let us see nitrogen oxide. The nitrogen oxide in the atmosphere are nitrous oxide, nitric oxide, and red brown nitrogen dioxide. The nitrous oxide originate from the microbiological process and occurs in unpolluted air at the level of about 0.25 ppm part per million. In the lower atmosphere, it has particularly no influence on the chemical risks, but at the higher altitude, it helps repair the ozone layer. It's very important. N2O radiations will dissipate in N2 plus O, and N2O positive O will react to form the NO plus NO, NO plus oxygen, ozone, or NO2 plus oxygen. So this is the process. Nitrous oxide with reaction that will form the nitrogen gas plus oxygen atom. Then this oxygen atom will react with nitrous oxide just to form NO. Form nitric oxide or nitric oxide will react with ozone, that will form oxygen plus nitrogen dioxide. So nitric oxide and pungent red brown nitrogen dioxides are the important constituents of the polluted air. These oxides collectively designated NOx enter the atmosphere mainly from anthropogenic source. Combustion of fossil fuel in both satisfactory and mobile source. The annual global import of the NOx is of order of 86 million tons. The overall process for the elimination of NO probably consists of its reactions with oxygen, ozone, or O in presence of third body to yield NO2. 2NO positive O2, that will form NO2. NO plus ozone will react, and that will be NO2 plus oxygen. NO plus O plus M, third body, NO2 plus M. The nitrogen dioxide is an important species in the atmosphere, or it absorbs the sunlight below 398 nanometer, undergoing the photodissociations, and above 430 nanometers, forming excited molecules. So NO2 in presence of radiations, that will form the NO plus O, or this NO2 with radiations will form NO2 star. It's an excited NO2. The photo dissociation of NO2 can yield a series of inorganic reactions beside a number of reactions involving organic species.